This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. We're going to find the y-intercept and any x-intercepts of this parabola, y equals x squared minus 5x minus 8. Okay, now the y-intercept, there's always a y-intercept of a parabola of this form. Remember, to get the y-intercept, we let x equals 0. Since every ordered pair on the y-axis, the x-coordinate is 0. So if we go up here, we're going to plug in 0 for x. We have 0 squared minus 5x minus 8. That's saying y is negative 8. So this gives us our y-intercept of, when you put in 0 for x, we get negative 8. So we know that is the y-intercept. Now we need to find the x-intercept, if there are any. There could be none, there could be one, or there might be two. So to find the x-intercept, we always let y equal 0, because every ordered pair on the x-axis, the y-coordinate is 0. So we go up to our equation up here, y equals x squared minus 5x minus 8. We put in 0 for y. We get 0 equals x squared minus 5x minus 8. Right, now we have to solve this for x, and we notice this is a quadratic equation. And so I'm going to rewrite it as x squared minus 5x minus 8 equals 0. And to solve a quadratic equation, there's different methods we can use. First, we could see if we could factor it. This one doesn't factor. So I could either complete the square, which could be pretty tedious because I'd have to take half of this coefficient, which is odd. I'd have a bunch of fractions. Or I could use the quadratic formula. So I'm going to use the quadratic formula. So the first thing I want to find out is what the discriminant is, b squared minus 4ac. For one thing, if it's negative, I'd be taking the square root of a negative number. There would be no x-intercept, so I wouldn't even have to plug it in the quadratic formula. So let's see what b squared, minus 4ac is. I don't know what happened there. I'm always having trouble. Okay, so we have equals. So b squared, since b is negative 5, then b squared is 25. Then I have minus 4 times AC. So 4 times, well, x is 1. I'm sorry, a is 1 and c is negative 8. So 1 times negative 8 is negative 8. So that's going to give me 25 plus 32, or 57. So 57 is the number that's going to go underneath the square root in the quadratic formula. It's a positive number, so we are going to get two real solutions, but they will be irrational because we'll have the square root of 57, and that's not a perfect square. So let's transfer this to the next page. All right, so we got that b squared minus 4ac equals 57. So when I put this in the quadratic formula, x equals negative b. So b is negative 5, so that'll be positive 5. That's the opposite of b. Plus or minus the square root of the discriminant over here, which was 57. All over 2a. Okay, now you don't see it, but a is 1, so 2 times 1 is 2. So this gives us two different solutions. 5 plus radical 57 over 2. Okay, and the other one is 5 minus radical 57 over 2. And now we want to approximate that, because if you were going to graph this, you would want to know approximately where that is on the x-axis. Like if somebody says, where is that? I don't know where that is exactly. Is it like close to 10, or is it close to 8, or is it close to negative 6? I have no idea. So you want to get out your calculator and put in 5 plus square root of 57 for the numerator, and then divide by 2. Now, if you're going to use a scientific calculator and do this all in one step, you do need to put the whole numerator in parentheses. So if you were going to put this in the scientific calculator, you make sure that you put a parentheses around the numerator. I'm kind of lazy. What I do is I put 5 plus square root of 57 and then I just push enter. That gives me the number and then I just divide by 2. So it's up to you which way you want to do it. So try that in your calculator. You want to do 5 plus square root of 57 for the numerator, or see what that is and then divide by 2. And then you're also going to do 5 minus square root of 57 over 2. Again, if you're going to do it all in one fell swoop, you'll have to put a parentheses around the whole numerator and then divide by 2. So for the first one, if we're going to round to the nearest tenth, which was the directions, I get 6.3. So it's approximately 6.3. When I did 5 plus square root of 57, that seems reasonable. It's 5 plus some number, right? And then 5 minus a number, I ended up getting a negative 1.3 when I rounded. So for my X-Intercept approximations, I had 2 of them. I put in y equals 0, so the x-coordinate was 6.30 and the other one was negative 1.30. This looks like INF. There were 2 x-intercepts. And then the y-intercept, that was the easier one. We just put in 0 for x in the original equation and we got negative 8. 0, negative 8. Alright, so those are our x-intercepts and our y-intercepts. You want to make sure you practice using your calculator. Now, you can also get an idea of what the parabola looks like now, if you wanted. See if this makes sense. The x-intercept was 6.3, so let's say this is, 2, 4, 6, 8, let's say. Negative 8, and here's 2, 4, 6, 8, 2, 4, 6, 8. So we knew that we had the y-intercept was down here someplace, and we got about 6.3, maybe that's about right here, and the y-intercept was about negative 1.3, maybe that was right here. And so the right in between the 2 x-coordinates, the x-intercepts is where the axis of symmetry should be. So it's somewhere, I don't know where it is exactly, but you could take the average, it's somewhere in here. So somewhere along this dotted line approximately, that's where the vertex is. So it's down here lower, so you can't really see the bottom of it, but somehow this is going down, right, way below. I'm not really showing the right picture, but you get an idea. Absolutely, it's not exact at all. So the y-intercept was not the bottom of the parabola. I just want to make sure you realize that. This goes down way lower. All right, so this is what we were asked for. And those are the answers we got. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.